Okay, well it is 5:10, so we will get started. Sorry. This week is on abstract data types and dictionaries. How do we feel about this subject? Quick temperature check. Meh. I will say, maybe this is mean, abstract data types are kind of useless once you learn object-oriented programming, which we'll learn shortly. But the main idea that they want you to get from abstract data types is the idea of the abstraction barrier. Have you been hearing that term pretty frequently? Yeah, it came up in your, I'm sure in the homeworks and the labs and whatnot. So what is data abstraction? A good example is like driving a car, right? When you're driving a car, all you need to know is how the steering wheel works, how the gear shift works, how the turn signal works. You don't need to know how like the combustion engine is, burning whatever, I don't even know. Or like the human body, right? We can live our lives without, we're not like consciously doing glycolysis or whatever, right? But we abstract that away and we just do the controls. So why do we want to do that? Well, it makes our code easier to read, allows us to reuse code in a cleaner way. And the big idea is it allows you to change implementations of a data type, for example. So let's say you made this restaurant, abstract data type that other people are using. Let's say in the future you want to change the implementation of a restaurant. Maybe it was a list and now you want to use a dictionary. As long as you update your selector functions, or the functions that get data from an ADT, along with your change to the constructor, other people's code that use your ADT does not have to be changed. And that's really powerful. So it allows you to kind of abstract away the implementation and allow other people to use your public-facing functions to do things. So abstract data types representing real-world objects with data types we already know. And the important thing to realize is there's not one right implementation to do anything. Sure, maybe some are more time efficient and some are cleaner or whatnot, but you can do it in a lot of different ways. You have two main functions with ADTs. You have a constructor and you have a selector. Can someone tell me what either one of those do, or what a constructor does? The name is kind of a hint. We're going to be constructing our ADTs, right? So that's what's going to actually make the ADTs. So for example, you might see you might have seen the make restaurant function, right? It took in the name of the restaurant and the location and whatnot, and it outputted a restaurant ADT. And the whole idea of the abstraction is we don't know how that restaurant ADT is implemented in code, but we don't have to know because we can use the selector functions, which takes me to the second point. What are selector functions? Well, those are going to get relevant data from our ADT. So keeping with the restaurant example, maybe it's get name, right? Get name, it takes in the restaurant ADT and it'll spit out the name of the restaurant as a string, right? So if maybe the restaurant ADT is like a dictionary where the keys are a name and whatnot, but you don't want to say, oh, I want the name of the dictionary, let me index into this, or I want the name of a restaurant, let me index into its underlying dictionary implementation. No, you want to use the get name restaurant that the creator of the ADT has provided you. So that way in the future, when that creator's like, actually I want to use a list, that function still works, your code still works, because they would also update that function. Any questions so far? Cool. Okay, so how do we abstract things? Well, like I mentioned, using the selector functions. So the idea of a data abstraction violation, all that means is you ignored those selector functions and you're like, I know what the implementation is, I'm going to dive straight into index 2 of this list, right? Like, you're not fooling me, I know this is a list. But that is called the abstraction barrier violation because you're not really supposed to be concerned with the implementation of an ADT. You should be sticking with the selector functions. Like I said, for a lot of reasons, it makes the code easier to read, and future implementations don't break your code. Yes?
Are you recording it for?
Yeah, I am. Yeah, no problem. Yeah, you're good. And then here's an example of an ADT with dates. So does anyone know what is this? What is this function here? this def date function? Is it a constructor or a selector?
Constructor.
Constructor. Why is that?
It's like building the ADT date.
Exactly. It is creating our date ADT. And we can see the code. So we know that the way they're implementing it is just a string with, so in this case, month, date, and year are all passed in as strings. You can see that in the doc test. And what they're doing is they're just smashing them together with a space in between. And you could see that if you printed it out. Okay, so then keeping in with that, now we have these selector functions, right? We have get month, we have get day, we have get year. And what are they doing? Well, they're slicing into the string. So if we made a date here, let's say this is Christmas, and we called get month on Christmas, and this is a really important thing. Your selector functions here, they always take the ADT as an input. And from there, they will give you whatever the selector is asking for. In this case, it's slicing up till 2, which makes sense. We want the first 2 indices of this string, right? So that'll get you 0 and 1, which in this case is this 0, 2. Or in this example, they'll get you 12, the 0 and 1 index of your string. And for get day, similar story from 3 to 5, because that'll get you the 3rd and 4th index, and so on. So we can see behind the hood here. We're peeling it back. But let's say someone else wanted to write code to find the next month, right? You pass in a day, and I want a month after whatever day I passed in. So, okay, I guess there's a special case here for when it's 12 and it loops back or whatever. But the basic idea is, you can see here, they're using get month of day. They're not saying day 3:5, whatever it was, or day 2, because we have a selector function to get the day for us. And at this point, we're kind of outside of the bounds of that ADT. So the code here isn't super important, but the basic idea is we are using those selector functions once we have made them. That way our code is much more cleaner, and if we need to make changes, we only need to make them in one place. And here's a question here. What if we did day 2 instead of get month day? Even though that is how it is implemented in the code, that is an abstraction barrier because you are effectively ignoring those selector functions. Okay, cool. How do we feel on that? Okay, cool. So do you want to take over for the problem?
So basically in this problem, what we are trying to do is that we want to basically just the solutions. Oops. Okay. Pretend you didn't see anything, okay? Because nothing happened here. What we're trying to do now is we're trying to make sort of like our ADT interface, and so basically like our goal is to make it such that our users can just call these functions, and as y'all were like just told, right? They should not need to know what's inside, and they should just have to call these functions, and they can interact with our ADT like without any trouble. So let's look at like the methods we have here. We have our constructor song that takes in the title, artist, album, and year of the song and stores it somehow. Get title takes in that ADT and returns the title, and get artist, album, and year do the same thing for the artist, album, year fields. And in this question, we were told to use a dictionary to abstract this, but they shouldn't need to know that. So, in our constructor, how would we construct a dictionary that would store all these values? If you need a quick dictionary review, remember that when we declare a dictionary, we use these curly braces, and we can map like anything to. We can map non-mutables like strings, true, false, numbers, etc. to literally anything, right? To like functions, to literally anything. So like, here's like an example of how you could declare a dictionary, just to jog your memory of the syntax. This is like the dictionary syntax, but so how could you like use a dictionary to store all these values? Yep.
Would you just map like the input a title to like the string title?
Yep.
And do that for each one. Like the key is the string, and then the value is the input.
Yeah, can you like tell me the syntax for the first one that I can write out the rest of them?
Oh yeah, title and the string, and then colon and
Yep.
colon. Title, like yeah, that.
The variable, yep. And we do the same thing for album, for artist, album, and year released. Why are we using these? Why are we using these specific key names? Well, usually you don't have to worry about them, but for this problem, they specifically requested that this be returned as our ADT, so we're gonna use their key names. But just know that for your user, the key names don't matter. And so you could just implement this just as well with different key names. Just for the sake of this problem, we'll be having those key names. Artist. So I just want to like open the floor while I'm writing this very messily to ask you all what questions do you have about this, about the concept, about like the first implementation, about like what the user needs to know and what the user doesn't need to know. Just want to open the floor right now. If you don't have any questions, that's all right. You can just feel free to interrupt me whenever. At least, let me erase this. Thank you. Just a comma here. Colon, year. Okay. So now that we've created our ADT, we need to now work through our accessor methods. So get title. What do you think get title should do? It says it here, but like the name intuitively gets the title, right? And so how do we do that? Using our current ADT, which is passed in as song. Yep.
Would you return? Oh wait.
Yeah.
It would be like. It would be like. Actually, would it be like song and then in brackets title?
Yep.
Okay.
And we return that, right?
Yeah.
So as you mentioned, this bracket notation basically just is used for any dictionary, very similar to a list, but instead of indexes, we have our keys. Just returns the value. Okay. So along those lines, does anyone have an answer for get artist? How do we implement that function? Yep.
Change the title into artist.
Yep.
Format.
And for get album. Yep. Is this okay? Yep, because the key is a string. That's like a mistake that sometimes people see. And also, if you have like variable names, like for example, like let's say like this is not the case right now, but let's say there's this album passed in, right? That could stand for something completely different, and so you don't want to confuse the variables with the keys themselves. Whenever you have a variable, you always want to translate it into what the variable is, and that'll be the key. And get year, I'm just gonna do it for y'all. Return song of year. And as you can see, and as I probably showed you earlier on accident, these are the solutions. They're what we wrote earlier. And I just want to open the floor to questions, and more specifically like conceptual questions as well. Yep.
So for selectors, will the input always be the return of the constructor?
The input will always be like what the constructor returns, and that's the ADT. Yep, you are correct. So how many of you taking data 8 here? If you remember, right? I'm from data 8. If you've taken it, you have to use like the package, right? The data science package, like, and you use like those tables, right? Like like those also have like functions and like selectors and stuff that you can get stuff from, right? Like there's like num rows, for example, which is like a variable, which you'll learn for more in classes. But like the concepts are very similar. You don't really know how that table works. You just know how to interact with it with like the with column function or and like how to change it using like adapter methods, while using modifier methods, which we'll go over later, especially when it comes to classes. But I just want to like bring up that example just to show that like you've already used like things like more like complex data types that you've interacted with without knowing the insides of them, and like you've been on the user end, right? And so like how like frustrating would it be if like the developers of that package the next day like said that now you need to know everything that goes inside making a table? Like, would you want to deal with that? No, right? That's like a waste of your time. And so that's like sort of what we're doing here. It's like we're sort of getting y'all used to both on both ends. Like when you're the creator, you want to make sure it's as user friendly as possible and that you can make big changes without the user knowing it. Well, if you're the user, we don't want you to like be that guy who goes into GitHub and looks at how a package is written and then tries to do some funny business and then your code ends up not working because the author changes the package. So always respect the rules of abstraction. Like for these questions, it seems kind of silly because like it's like, oh, this is so small, right? But trust me, it gets really, really big. And if you can't respect this barrier, you'll get into a lot of trouble later if you decide to develop any software. And so here's our. So firstly, like, do you have any other questions about the previous problem? What other questions are there? Okay, so we'll move on. But if you have any other questions, please interrupt me. So now we're going to implement the group songs function. And this function takes in a list of song objects and returns a dictionary with keys as albums and values as the song names in that album. So basically we have like a bunch of songs, we pass it in here, and we just want to group them by the album they're in. Group like the song names by the albums they're in. And so from the previous problem, we can see that our song ADTs have the album and the titles in there, so we can definitely like group them together because we have all the information we need. So I want to start like in words. What do you think we should do here? Like we have like our list of songs. What should we do in words? Yep.
Use a for loop to go through each of the songs in the list, and then use the selector functions to take the
albums
and then
title.
Yeah, albums and titles, and then add that to a dictionary that you're making.
Yep. And so that dictionary, when would we create it? Inside the for loop or before the for loop?
I'm not sure.
Yeah, it's all good. Like this is like we're already like a few levels deep into our thinking, so like it's a bit complicated. Yep. Yeah. The reason why we do it before the for loop is because if you do it inside the for loop, right? This is a mistake I've seen many times. Is that you end up recreating your dictionary over and over again, and then like you're like, oh shoot, like why is it so small? Like I add like 100 things to this, like oh, and the reason why it's so small is because you've been recreating like you made 100 dictionaries, and each of them has one thing in it, and so it's like a trap that you can avoid. And so on those lines, let's start by creating our dictionary. Does anyone want to let me know how you create an empty dictionary? Yep.
You would set D equal to like the curly braces.
Yep. And behind her, how would you start looping over the different songs?
Maybe for song and songs?
Yep. So basically now we have our dictionary which we're going to store everything in, and we also have, and now we're also going through every song in songs. And so, what were the two things you want to get? The title and the album, right? So can you walk me through how we'd get those? So we'll say title equals what?
Get was it get title?
Yeah, it's get title of
song.
yep. And what would album be?
Get album of song.
Okay, and now comes what I think is the hard part. It's like the hardest part of the problem, sorry, is adding it to dictionary. So how would you, so if you notice down here, what you want to return is that the name of the album should be mapped to a list of song titles. You already have the album name, you already have the song title name. So now how would you, so like, what's the process you want to take for adding this into the dictionary? It like sounds kind of simple, like because like normally you just like add it to the dictionary, right? But since we're working with the list here and we're going to be adding things to the list, it gets a bit more complicated. So does anyone have any ideas how we're gonna deal with this? Yep.
We have to check if album, the key is in the dictionary.
Yeah. And do you want to explain why we have to do that?
Because if it's not in there, we have to like create like the key. And if it's in there, we can just append this.
Yep. And so does everyone get that? Did everyone hear that? And the reason and if we don't do that, what ends up happening is that we're gonna try and access an album that's not in the dictionary already, and we're gonna get a big error, and we don't want that. And so if it's in the dictionary, what do we want to do? So basically, what this condition is saying is that we already have some songs from the album in the dictionary, and it's already in the list. How do we add our song to the end of that list? Yeah? So how would you write that in code?
Album.append.
D of album, right?
Why is it D of album?
So currently, right? Like let's say we're in a state where like we have sheer heart attack as our thank you. I'm just gonna call it SHA because I'm lazy. HA as our album name, and currently we have SR, Seaside Rendezvous, as our value. And so if you just call it an album, right? This album is just a string. What we want to append it to is the key is the list of things that the album is mapped to. So that's why we have to call it D of album.
Yeah.
Yep. And so then what do we do after that? D of album dot
Append. And then title.
yes. That's good. And so now, what's the else case? What if we don't have a mapping yet? Yeah. Is this enough? Yeah. This is like not just here but in recursion. A lot of times we got to make sure we're working the same types as everything else. And so always remember to keep everything the same type. If we just put title without making it into a list, we would end up calling append on a string, and bad things would happen. Don't let bad things happen to you. And now, are we done yet? Yeah?
Oh, I had a question.
Yep.
For the if album in D, does album represent like the index number in album or like the actual value? Does that make sense?
Yeah. I see what you're saying. So album is like a variable which contains like a string, right? Like for example, sheer heart attack. And like and that's like kind of a key, which is like sort of like an index in a dictionary. You can think of it like as an index, sort of, right?
Oh.
It's not the same thing, but it's like you kind of use it the same way as you would an index, right?
So album is like the album name?
Yeah.
Oh, okay.
And yeah, we get the album name here.
How can we append title to that then? Is there like a corresponding?
So we're appending title to D of album. So what is D of album? D of album is the list that is mapped to the album name. So this would be like, for example, right, in a 2D list, right? Let's say we have a list that's like this.
Oh, wait, I see now.
This would be like we're appending to this list.
Yeah, I got it. Oh, okay.
Mm-hmm.
Thank you.
Okay, and are we done now? No, why not? Yeah, return D. Yep. Yeah. So, look at that for a second and let me know what questions you have. Because that was a bit, right? That was like a few different steps we took. An algorithm we had to come up with our looping. And, yep.
In the answer here it says we can plus equal. Is that the same thing as append?
Yeah, so there are different ways to add stuff to lists, which is why like usually like I don't know if you noticed, but the list section of your labs were probably pretty mini lecture heavy for the most part, because there's like so many random functions you have to know, and so another way to add to a list is to do like if you do 1 plus 2 comma 3, it gives you 1 2 3. And so you can use the same logic. So if you have a list, D of album, to add something to it, you can do plus equals, which is just like D of album plus, and then title in its own list. That's just a similar thing. The nuances of why it's different are beyond the scope of this class. Just know that like it just does different things. Yeah.
Can you explain that like else statement one more time?
Yeah. So you gave me the solution for the if statement, right? And do you sort of understand this?
Yeah.
Yeah. So like the else statement is basically like in the if statement we already have something in here, right? And so we're appending to that. In the else statement we don't got anything in there. We don't even have a key. So we need to have like a base to like we need to make our foundational list to start building off of. And so what we do is that we create a list. And since we're going to add title to it anyways, right? We just put title in that list at the beginning. Another way of doing this, right, would be if album, we don't have this if else. Instead, we have if album not in D. We do D of album equals an empty list. And then we have this line anyways. Here, let me write on the side. Like another way of doing this, right, would be you sort of see like basically we just need to like have something to build off of.
Yeah, I see.
Yeah, this is just doing that in 2 steps.
Okay.
Yep. Do you have a question? No. Okay. So like another thing that I want you to remember is that like on exams, questions can get complicated. So a good strategy is to like instead of just jumping right into it, almost like a fill in the blank, you definitely do want to like try and plan out what you're gonna do beforehand. And the other strategy that we didn't go over this time is that you should definitely try and run the doc test like on like an environment diagram on the side of your paper, or like even if it's not like a full-fledged environment diagram and you make some mistakes, it's still better than doing nothing, because you can find a lot of mistakes just by like running through your code in your head. That's kind of what I wanted to go over with that. Yep, and the solution. Yeah, so the only differences here is that we made a variable for get title of song called title to make it look a bit clearer, and they used the plus equals thing and we used the append. Does everyone sort of see how this solution maps to ours? And so now I'm gonna leave this here, but it's attendance time. So please do your attendance. It gives you points, not like towards like if you're at the borderline of 2 grades, we can bump you over if we see that you've given enough effort in like attending a bunch of these. So yeah, yep.
Password too?
Oh, the password.
Oh, right.
Yeah. You want to set the
I
password?
can write it on the. Oh, sure.
Yeah, I mean, I've done it every other week, so.
That is. That's a lot of pressure. Password, we'll say abstraction. Kind of boring, sorry. Small. You want to write it on the iPad too.
Yep. Is it lowercase or uppercase?
Yeah, we'll do lowercase.
Mm-hmm.
In the answer there, when you're seeing if the album is in the like dictionary, in the answer it says song Dick keys in the parentheses. Is that the same thing as just saying if album in D?
Yeah.
Okay.
What song dict keys does, it just like gives you a collection of all the keys. But the creators of the dictionary in Python were smart and they knew that like we'd be doing that a lot. So the default thing to do when you use the in keyword on dictionary is to look at the keys.
Okay.
Mm-hmm. That's a good catch though. I did not notice that. Do you wanna?
Sure,
Yeah.
Sorry. Okay, cool. So we're gonna kind of pivot now. We're still gonna be using dictionaries, but how do we all feel about recursion? Spooky, scary. Yeah, exactly. That's all I felt when I first learned it. Recursion is scary for sure. It's very hard to wrap around in your head. I think there will be a time where it might click. Hopefully that can that can be soon, but it's definitely tough. But we're gonna work through this problem together, and maybe by the end of it, you can have a better understanding. So what are we doing? Well, we're managing orders for a restaurant, right? So let's read this. We want to implement this function, add new orders, and that's going to take in a dictionary, all new orders, and that's going to represent all the orders that the chef currently has, right? But we are going to mutate that dictionary to include the new orders from a list called new orders. So before we go on, can someone tell me, are we going to be returning anything from this function? No. Why not? Why are you shaking your head? It's okay. We are basically going to be changing the dictionary that we pass in, right? So what that means is we're going to be receiving a dictionary, we're going to change it, and we don't need to return anything because all we did was change that dictionary already. So in the last problem, we were creating a new dictionary, right? We were creating a dictionary where songs are grouped by albums. In this case, we want to take in the dictionary and update it with the new list of orders. Cool. Now this new orders list, it's a bit strange. It's saying here each element in the list is a tuple. A tuple is just a immutable list. but it shares very similar qualities to a list, with the only exception being you can't write to it once it's been created. And the first element is the food item, and the second element is that item's quantity. And what it means by quantity is like how much of that are we going to add to our current set of orders, right? So let's look at an example. Right now, the current dictionary of orders that they give us is that we have 3 fries and 4 burgers. And notice here the keys are the food item, and the values are the quantity, how much of that, right? And then we're going to call this function that we're going to write. We're going to pretend that it already works. And when we call it, we're going to call it on the dictionary we just made. So that's the previous orders the chef has. And we want to add the contents of this list. Now notice this is a bit weird, but every element of this list is a tuple, right? The first one, and the tuple, the first index of that tuple is the food, and the second index of that tuple is quantity. And it's going to move on. From there, our order dictionary should now have updated fries by 4, and made a new milk entry and added a quantity of 2 to that. Okay, cool. So there's plenty of ways you could do this problem. We could do it using loops like we have in the past. That seems pretty intuitive. But we're going to be ruthlessly mean and make you lose recursion. And that's another thing to note. It's like some problems, like it makes a lot of sense to do recursion. I'm going to be honest, this one, it kind of doesn't. I mean, you can, but like, if I were doing this problem now, I would just iterate through new orders and do it that way. But it's a fun way to get us to get engaged with recursion. But it's important to realize that there's multiple ways to do this problem. A lot of times you'll see a problem and it'll be like, here's the iterative solution and here's the recursive solution, right? You normally don't see those. You normally see both of those solutions. Okay, so recursion. There's 2 fundamental parts to every recursive problem. We have a base case and we have a recursive case. And the basic idea is our recursive case is going to be calling on the function that we are actively creating, which is a bit weird. But notably, it's going to be calling the function on a, let me make this purple, smaller input. Because what would happen if we kept calling it on the same input? We just go on forever. Yeah, right? Because we're not breaking down the problem at all. And that's the whole idea behind recursion. We have this big problem, but we can break it down into steps. So is there any ideas about how we could break this problem down into steps? We have our dictionary here, and we have this list of our updated orders. How can we kind of break this down? Yes?
So probably kind of establish the base case?
Yes, exactly. Okay, so our base case is going to be when we have reached the end of our breaking down problems. And now we want to return like a definite value so that we can work our way back up, or just return at all. So any ideas for what our base case could be? It's kind of tricky because it requires us to know how we're going to do our recursive case, right? We need to know how we're breaking down the input to know when we're done. But is there any ideas? Yes?
When new orders is an empty list, like there's nothing else.
Yes. So when we could say like new orders equals an empty list? Yeah, okay. Can you give me the thought process behind that? What made you say that?
Because if there's still like names and quantities in, it's gonna either add on to the existing keys or like create a new one.
Exactly. So what your kind of model now for this is to say, for every function call we do, we want to evaluate one of these new orders, and then we want to call on the same function with any of the other orders, but with the order we just handled removed. Is that right? That's a great idea. Because then when we do that, what we're doing is we're effectively knocking down new orders by 1 order every time. And if we do that enough, so first we have this fries. I'm not going to fill it in completely, sorry. Milk. So when we first call this function on this new orders, what we're going to do is we're going to handle this first element, fries and its quantity, right? We're going to update that in our dictionary, and then we're going to toss it out, and we're going to call the exact same function on the list with just the milk order, right? Because it's effectively going to be doing the same thing. We're going to handle the first element. We're going to, by handle I mean like update our dictionary, and then we're going to throw it out. So we update it and we throw it out, and then what are we calling the function on? Nothing, right? Everything's been removed. So that's when we know we are done solving this problem. And that's the whole idea of the base case. We have broken it down all the way, and we are done. And that's exactly what we're saying here, right? If new orders is an empty list, then we're done. Start exiting these function calls. And then once we do that, we return here. And that means we can resolve this previous call, right? Because this call, the call that was made here is now resolved because this was returned. This was waiting on this to get like a resolve. And now that this call is done, this call can now be like, okay, my further calls were done. And it's going to work its way all the way back up the chain, and then we finally return all those calls that we made. So I think we have a good idea, right? We don't have it in code quite yet, but we have the idea. Any questions on that before I start writing any more code? This is very confusing, so. Okay, cool. It looks like they give us a bit of starter code here, right? Food item and quantity. Can someone tell me why there are two indexes here? That's really weird. Why is that happening? Yes?
Your second input is a list, so you have to index twice to get like the items inside the tuple.
Exactly, right? Because we are passing a list of tuples, right? So if we want to actually get to anything meaningful, when we do new orders of 0, let's say it's this passed-in list, new orders of 0 is going to spit out this tuple, fries and 4, right? That's what new orders of 0 gets us. So what we want to do is we want to set the food item equal to the 0 index of that tuple that we just pulled out. And we want to set quantity to the second index of that. My question, why are we only ever indexing, why is the first index always 0? We have so many more elements in this list, right? Why are we only doing the 0th element? Yes?
Because we're always going to slice off and always do the add.
Does that make sense to everyone? So when we're doing recursion, we're going to be breaking down our problem into subparts. So we don't want to be jumping ahead to the later items in the list because we're going to make a function call that's going to handle this. Right now, in this function, we are dealing with the current frontmost element of our list. Awesome. I love it. Let me just give myself some room here. Okay. Cool. So now we have an idea of what we're doing, right? We have a fries and we have a quantity. How can we update our dictionary? Right? We have the current input we're on. We want to handle that input and call the next one. So how do we handle the input? How do we update our dictionary? Looks like we have an if-else here. Yes. Oh, sorry. Do you want to take it? Yeah.
I'm not sure if it's good, but would if the if statement would be if new order is not empty?
If new order is what, sorry?
Is not empty, so like the exclamation mark before the empty.
Ooh, okay. What's your thought behind that?
My reasoning?
Yeah.
It's like not the base case, so not the base case, I'm gonna just keep it on.
Gotcha. Okay. So one thing to note is like if that were the case, so if we follow this chain of commands, right? Let's say new orders was this empty list. What we do is we return. And returning is going to exit us out of this function. So we're never going to run this lines of code in the event that, so like basically what I'm trying to say is like, if we even get to this line, this food item line, that means that new orders does have stuff in it. Does that make sense? Because otherwise we would have returned and we would have bailed, right? We would have gone out of there. So any other ideas? What is that statement? Yes?
We want to check if the key matches the one that's already in the original order.
Right. So what's the key? What's the key in this example? The food item. Okay, so can you tell me what that line of code looks like?
The food item in
I think it's all orders, right?
yeah.
Exactly. Right, and like we said, the in operator is going to be checking it against the keys of all orders. And if we look at this example, let's say right now we're handling the fries example, right? If we look at order, we see that, oh, we do have fries, right? So that means there is an element associated with it, or a value associated with it. And in this case, values are numbers, right? They're not lists or anything, it's just a number. So what do we want to do to that number that's associated with fries, right? Because we know it exists. At this point, we know that value exists because that if statement passed. Any ideas? Yes?
We want to add the value to the original list, or to the all orders list? To the new orders? Or add it to something, right?
Yeah, so add what exactly?
The value of food item? Or
The
quantity?
quantity of the food item, right? So the basic idea is, this is our dictionary right now, and we want to add an order of 4 fries to this dictionary. So we should end up, this entry in the dictionary should become fries 7, right? So if we know that that key exists in the dictionary, how can we update its associated value?
Oh, isn't it like update dot dict or something, or update? I don't know.
You're on the right track, yeah. So we do want to index into our dictionary, right, based on the key. So we could say all orders, and we'll do our bracket notation, right, so that we can get the value associated with the key. But what's the key? Can someone remind me? Food item, right? That's the keys of these dictionaries. And remember, we know, like we have complete 100% certainty that this entry already exists in our dictionary. Why is that? Because it passed this if statement, right? We are inside this if statement. So we know there's an entry there. What do we want to do to the value associated with that key? Yes? Plus equals quantity, exactly, right? Does that make sense? So if we go back to this example, we're saying if fries, right, in this example, if fries is in our dictionary, oh, it is. We want to take that value here, and we want to add 4 to it, right? And look, that's what we do. It becomes 7. And notice it's plus equals quantity. A lot of times you might see it's like equals 1 plus equals 1, right, if you're like counting things. But in the example here, we're given a quantity, so we want to add that quantity to it. Cool. How about for the case where that key is not in the dictionary? We want to give it some default, some starting value, right? So all orders of food item, right? We want to create this entry in the dictionary. What do we want to set that initial value equal to? 0, 1, yes. Quantity, right? Because we know how much of that item there is. And we see that in the milk example, right? We pass in this order of milk with 2, and it ended up being in our updated dictionary. Cool, okay. Now we get to a crazy part of the function. Now we need to call this function on a smaller subset of our input. So remember, we just handled the first element of our list, right? Or the tuple, I guess, the first tuple of our list. How can we modify our input in our new function call so that we don't consider the same input that we just did? So remember, it takes in the dictionary, all orders, and it takes in new orders. Which of these parameters do we want to change? Yes? You say new orders? Yes, exactly. All orders stays the same, right? Why is that? Because it's our dictionary that we're mutating, right? Okay, how do we want to change new orders? You said slice? Yes. Right, and what are we slicing off exactly? The very first element, right? Because in this function, we only considered the first tuple in the list. So the way we can do that is use slicing notation and say, is it new orders? New orders 1 colon. What that's going to do is it's going to exclude the first element, but give everything else. And now, that's going to, what just happened? That's going to create this call, right? Where it's just doing the milk order. It's going to add that milk order to the dictionary. Then it's going to create this call that's empty. So we're going to terminate that, terminate that, terminate that, and we're done. And our dictionary is updated. Okay, that brings us right to 6. Thank you very much. I hope that was helpful. And there's the final solution. Yes?
Just a quick question, is the midterm on paper or?
Do you know?
I think there's gonna be options.
I think there's an in-person and online option.
Yeah.
If we take it in person, it'll be like on paper?
Yes, probably.
Yeah.
Yeah, of course.